Well, hello and welcome to Reliable Web Summit. This is Craig Shoemaker. I'm really glad you're here with me today. Today we're going to be talking about building reliable systems with Azure Static Web Apps. And if you want to get a hold of me on Twitter, I have my handle here at the bottom. That's also my GitHub handle. And speaking of GitHub, probably the most important slide of the day is this slide right here. And so if you follow this bit.ly address, it'll take you to the repository that has a demo for this talk. Now, we're building an application that has two parts. So there's two repositories for the demo that we're building here. And this one link will get you the access to both places. So it'll take you to the UI layer and it'll link out to the API layer, but there's nice documentation there for you. Everything you need is all right here at this bit.ly address. So let's talk a little bit about the app that we're going to build today. Let's say that you're building a site for a volunteer organization. And you need this to be able to handle a lot of traffic. You're expecting a lot of people to come in and want to be a part of the organization, a part of the effort that you're doing. So you want to take volunteers. You want it to be fast. You want it to be reliable. But you also want it to be painless for development and also for maintenance, meaning that you aren't wanting to be responsible for all the tiny little details when it comes to uploading files to the server, setting up the server, setting up CI/CD, managing domains, all of that fun stuff. So what I'd like to do is show you how you can use a number of different Azure services to stitch together a solution that fulfills all these needs. So the app itself, we have this very simple volunteer UI. And so you'll come in, add in a name, and what that's going to do is start with the web app and then make a call out to an API endpoint. So it'll just take this data, wrap it up, send it over to the endpoint, and that API is going to talk to a couple different storage mechanisms. First, it'll add a message to a message queue. So we can add as many messages as we need, build up that queue, and then we'll have a function running in the background, a little piece of code that says every time there's a new message that shows up in that message queue, it's going to take that data and store it permanently into a table. So we're going to go from the message queue to a database table, and that's all going to run completely in the background. Now, the services that we'll be using in order to make this happen are Azure Static Web Apps, and this will give us the opportunity to build, maintain, and deploy our web apps in a very easy workflow, and you'll see how that looks in a moment. We'll use Azure Functions as the backend for the API endpoints, and we'll use Azure Storage to handle the message queues and the tables. Now, what's interesting about this talk, there's a nuance here that shows you how to use Azure Static Web Apps that's different than what you get out of the box, because normally there's a restriction between the type of APIs that you can implement. Usually you have what's called managed functions, and you can only use certain triggers. And a trigger is a way for a function to begin running. So what I'm going to do is show you how to glue an existing Azure Functions app together to a static web apps instance. And then that way we have the full capability available for Azure Functions. And at that point, we get to have an HTTP endpoint to where we send our data. But then we also have a function that triggers anytime there's new data in that message queue and then store it to the table. Well, let's go. Let's take a look at it. So here is the demo application. So I have this running locally, and then over here is my table. I'll refresh. You can see there's nothing in the table. What I'm going to do is type in my name. I even spelled it right. Click sign up. And so that's blanked out now, which is fine. Refresh the page, and then you can see over here that in the table, we have a partition key of a volunteer, the row ID giving its unique identifier, timestamp, and then my name. So that's the whole workflow working together. We couldn't see it because it happened so fast, but behind the scenes, it hit the endpoint. It went into a message queue. That message queue ran some code that then said, take that data and store it within the table. All right, so let's get started building this together. What we're going to do is come over to this repository. Now, this is the bit.ly address that I gave you in the beginning. And so the only difference is what I've done is gone to /generate from that repo. Now, I've set this up as a template repository, so it's really easy for you to get your own version of this app. So let's start off and call this Reliable Web Summit UI. And I can have this as public. Private works just as well for what we're doing. Either way is fine. I'll skip the description I'm going to go ahead and create my repository from the template. Once that's done generating, then what we can do is clone that repository down to my machine. And so I'll do that here by clicking on the URL. And then I'm going to come over to my bash shell and stop this little local server from running. And let me go back to my correct location for where we're going to put the demo app here. I'm going to put this in my sandbox. And clone it here. Okay, so now we're going to switch into that folder. Oh, I did AUI. Oh well, that's all right. We'll run with that. AUI it is. And then I'm using Visual Studio Code. I have the insiders build. There's nothing insiders about it. It's basically just the nightly build of insiders. So if I do code-insiders and then space period, I will open up Visual Studio Code within this folder. So let's take a look around at some of the code that's in here. And it's pretty simple. It's really just an HTML file. And so this is your basic HTML construction. Essentially what's going on here is we have two things on the screen. So I have a button and I have my input element. The important part here is that the unique identifier within HTML is name. So that's easy to get to. And the unique identifier for our button is sign up. So that should be easy to get to. Now I wrote this code on purpose using just plain old JavaScript. I didn't want to have to worry about any frameworks. So whether you like React, Angular, Vue, Svelte, or anything else under the sun, basically you'll be able to run this and hopefully this will be pretty familiar to you. So I want the script to run once all the DOM elements are ready within the browser. Then what I'm going to do is look for the sign up button. So once we've got access to that, then I can create a click handler for that button. Once we click the button, what we want to do is take a look at the name text box and extract the value out of that box. Now what I'm doing here is just creating a little transfer object here. So I'm creating this data object that has the value out of the name text box and setting it equal to a property called name within the object. And then we use the native browser API of fetch to do a post. I always think that's weird. But what we're going to be doing is calling fetch to the location of /API/signup. Now what's interesting is that we're actually running two separate applications, and what Azure Static Web Apps will do in the background, whether we're running locally or whether we're running in the cloud, is stitch those two together so that the web server thinks that they're the same application. And so what that means is we don't have to worry about CORS errors. We don't have to worry about any sort of linking between the two because the service is going to do that for us. Locally, we'll use a CLI to make that happen. And on the cloud, it just happens automatically. So we're going to make a post and we're going to set everything up to run, use JSON, the content type of JSON. And I'll take that object that I created, serialize it so we can send it over the wire by using json.stringify, set that equal to the body and ship it off. Then after that, I'm just clearing out the name text box. You don't want to do that in the real world. Obviously, you want to have some error trapping code. You want to worry about edge cases. You want to figure out, display some errors to the user if something goes wrong. But I try to keep this simple just for demonstration purposes. Okay, so this is our app. So what we want to do now is create this web app as an Azure Static Web Apps instance up in Azure. So what I'm going to do is come over here and first I'm going to show you extensions. So I have this installed already, but there's a VS Code extension, and if you spell everything correctly, it tends to show up better. And this is the Azure Static Web Apps extension. So obviously mine's installed. You want to look for this. This extension is phenomenal when it comes to building these services because I can do everything here within VS Code. So what I'm going to do is use the Azure Static Web Apps extension, and I come over here and I'm going to close out a bunch of these other extensions that want to run when I come over to the Azure section and just stick with Static Web Apps. So what I'm going to do is create a new static web app. Now, I want to use whatever subscription. Here I have a research and development one that'll work fine, and then we'll give it a name. I'll stick with a typo just to keep everything consistent, but here I'm just calling it the name of the folder. And then I get to choose what kind of code is running on the front end of this app. You can use Angular, React, Svelte, Vue, Blazor, build a Gatsby app. So yeah, it's not even a fully front end, but basically this is the build type of steps that Static Web Apps is going to use. I don't need any of that because I just have plain HTML and JavaScript. So I'm going to come down here to custom. The first question it'll ask me is the location for my application code. And again, it's very simple and very basic in this, this example. So this will just be /. So I'll go with that. Next, it wants to know the build output relative to my app's location. Again, not doing a build, so I'm just going to go with / there. And once I do that, now it's going to start building this static web app for me. So you'll notice it already created the static web app. And now when we come down to the extension, we can see the status that's happening during the build process. What's happening at the moment is that it took the Git repo, it added a workflow file to it, and then kicked off a GitHub action. Now, a GitHub action is basically a background process that's running. So it's doing the build process, and it's going to deploy my app for me. And we can watch and see how this works during that whole process here. We'll come back to that in a moment. First, what I want to do is come over here to this new folder and a new file that Static Web Apps added into my project. So it's this YAML file that has a bunch of stuff in it, but really right here where you see the commented section, this is what we're most interested in. Now, if you remember, during the time when I used the extension and I created the app, these are the answers to the questions that I had. So I had my app location, so that's the root of the project. We'll skip that API location for a moment, and then output location. Again, no build steps, so we're going to go with /. Right now, this is set to API. This will change in a moment because what Static Web Apps wants to do is point to a managed or an internal type of API, and we're going to separate those out and use an existing Azure Functions app. So we'll come back to this in a little bit, and right now, let's go back over to our extension and see that it's still waiting for deployment. Okay, well, let's dig into the actions a little bit here, and we can see what's going on directly in here. So the build and deploy job succeeded, a few seconds, and let's see, job is complete. So if we refresh this, there we go, it's all done. And so I can come over here and browse to the website. And now I have my app published in public. That's great. It's not great though, because there's still more work that needs to be done in order to hook this up into an API. And so let's do that portion of it next. Okay, so here I am within Azure, and what I want to do is create an Azure Functions app. So we'll come over here to Function App, and I'm going to click on Create. And this will bring me to the Create page. So here I'm under the same subscription, and let's figure out what resource group. Nah, never mind. I'll just create a new resource group called Demo. It's fine. This can be in a different one than our Azure Static Web App. Give it a function name. So let's do CRS, Reliable Web Summit, API Demo. That should be available. There we go. And I'm going to be running just straight up code. This is going to be in Node.js. We'll go with 14 LTS. Sounds good to me. And I'm on the East Coast, so I'll select that. So if we go into storage account, I'm going to create a new one here. Let's see, what did we call? Keep these names consistent so that I can find it easier. And I'll suffix it with storage. That should be available. So there we go. And at that point, we can just go ahead and create the application or the service itself. So this creates an Azure Functions service up in the cloud. And so what we'll do now while this is running is go and create the files for the Azure Functions app. This will take a moment to get going. And when we come back, we'll be able to configure the storage account of where we're going to save our data. All right, so back to Visual Studio. What I want to do here, though, is come into my sandbox, and I'm going to delete this old one here and create a new folder. And just to keep things consistent, I'll keep my typo, but Reliable Web Summit. Well, we'll call this one API. So we have AUI and API. I'll open this one up in Visual Studio Code. And now we can create a new Functions app. So this time I'll collapse all of these other ones. And now I can create a new Functions app. So we'll use the current folder. That sounds good to me. We're going to be doing this in JavaScript, and now we get to pick the trigger type for our very first function. So this will be the primary endpoint for the API. This is the place where we're going to send the data to the Functions app so they can create that message queue. So I'll pick HTTP trigger because I want to be able to send a post request to that endpoint. And the first one we're creating here is called sign up. So the volunteer gets to use the sign up endpoint in order to point to that. For demonstration purposes, I'm just going to pick anonymous as an authorization level just to keep things simple. And so now when we come over and look in Visual Studio Code, it generated a whole bunch of files for us. And here it created this function for us. So here in the folder of sign up, this gives me the sign up function. This is powered through basically two different files. We have the metadata file, or the function definition file, in function.json. And this has all of our bindings that says how it's going to trigger, what services it's going to talk to, all that fun stuff. And then we have index.json, or excuse me, .js, the JavaScript file, which implements the logic for our function. So let's start off with the function JSON in and of itself. So what I want to be able to do is, like I said, this is an HTTP trigger function. So I'm going to send a post request to the endpoint, and it will recognize that request and do something interesting with the data comes in. But what I also want to do is be able to output the data that comes in into a message queue. So first thing we'll do is edit the methods here, change that to just be post within that array. So now I'm restricting it to only be for post requests. And then what I'm going to do is say that I want the output of this function to be able to go out to a message queue. Now, the parameter that we'll be using in code will be message. The queue name in the storage account will be messages, and we'll use the storage connection string in order to talk to that service. Okay, so we've got that. And then all we need to do at this point is just update the logic that's within the function itself in order to make that call. So let's get rid of all this boilerplate code here, and then we can put in basically 4 lines of code in order to make that happen. Now, that's kind of the value of using these bindings within Azure Functions. A binding is just some code that's been pre-written for you to talk to other services. So at this point, what we're able to do is use this declarative approach that we've done here within the function JSON to say, hey, I'm talking to a message queue. And now within the function itself, I can just say context.bindings message. Now, this property gets its name from this declaration right here. So name equals message. So context.binding message equals the request body that's coming in, which is basically that data transfer object that says name and then whatever name is provided. Once we've done that, we call context done, and that's all that's necessary in order to write out that message. Let's go back to the portal for a moment, and we should be done. Perfect. Go to resource. And then I'm going to go up to my resource group, and I'm going to find the storage account. So here's the storage account that we're using in order to save the data. And there's a few things that we want to do. First of all, we want to come into queues, and I'm going to create a new queue and call this messages. So I'll add that. And then we want to create a table and call this volunteers. Okay, so we have the message queue and the table. Both of those are available for us. Now we can come into access keys and get the connection string. So with access keys, what I can do is come and click on show keys. and copy the connection string. Once I have the connection string, I can go back over to the Azure Functions app and go to the local settings JSON. Now, this is a place where we can store essentially application settings for the application. So I'm going to put in my connection string for Azure Web Job Storage. Now, the functions needs that, Azure Functions needs that in order to save a little bit of state information as it's operating, so that's necessary. I also have another connection string that I want to use, and so I'm going to add this in. It's the same connection string, it's just under a different name. So let's do that. And what do we need? A comma, got that? We need the comma here. Okay. And I chose storage connection string just because I wanted the demo code to make sense, because, you know, what is Azure Web Job Storage? Nobody really knows. So I'll just call this storage connection string. Either way, whatever the Functions app needs, it's going to be able to find it through these two keys within the configuration. So I've got a connection string now, and I have the logic saved, and I have everything here in order to run the function. Again, that's our primary endpoint. This is the one exposed through HTTP. So now we have another function that we need to run, and what that will do is run every time there's a new message within that message queue. It'll take the information that is incoming from that message and then save it to a database table. So let's create a new function to make that happen. So I'll come over here and create a new function. This time what we're going to do is trigger off of, let's see, Azure Storage Queue Trigger. That works for me. And this one we're going to call save. When I reference my handy dandy notes. So storage connection string, that's what we're going to use. That seems to make sense. And let's see, this is the name of the queue on which the messages will be read. So we named that messages. So we'll do that. And so now we have this function generated for us. Let's come back over to our Explorer here and take a look and see we have a function JSON, and we have that, oops, sorry, that's sign up. Let's take a look at save. So we have a function JSON and we have the index.json JavaScript file. So let's change this metadata up just a little bit. And what we want to do is keep what's there, but what I also want to do is output this data to a database table. So we'll add this in. So we have an output binding, and we are talking to a table. The name within code that we're going to be using is called volunteers table, just to keep it explicit. The table name within our storage account is called volunteers. And again, the way we'll access it is through the storage connection string. So then all we need to do is just update the JavaScript that we're using in order to work with the message queue, and also with, sorry, I'm just going to close some windows here to keep things tidy, with the storage queue and also with the database table. So let's close all that out, and then we are in save. Let's go back into index.js, and then I'm going to replace this boilerplate code with this other code. So the first thing that we see that we need here is this module called UUID. Now, that's because what we want to be able to do is give our data its own unique identifier. And so the easiest way I know to do that is to just use a GUID value. So we're going to install that package now. So I can do npm I for install and UUID. It's important to spell that correctly so everything works right. And so we've added that in. Now we have that package available. So here, now when the function runs, it's going to run here. And at this point, I'm just creating an object that basically glues together the composite key for the row. So the partition key, like you saw in the beginning, was volunteer. You can use a partition key to create groups of data within your table, within Azure Storage or Azure Table Storage. And so here I'm saying all the volunteers will be under the partition key of volunteer. You might have clients, you might have admins, you might have all kinds of other things you want to do, but this will work well for our volunteers. For the row key, for the actual very unique part of the unique identifier, I'm going to generate a GUID by calling uuid.v4. And so once I have that, I have the unique identifier for the row itself. Then I can use the spread operator in order to glue together my two objects. So I have the object that has the ID information, and then I have the message that's coming out of the message queue. So I can take both of those and put them together in a new object and just call this row. So then I can call context bindings. We're going to look at the volunteers table and add a new row to it. Again, remember, volunteers table, the way that we got that value was because name property within the binding information here, the name property is set to volunteers table. That shows us how it'll show up in code. All we need to do is call context.done, and that will run for us. Okay. Let's try this out. Let's see how this works. So I have another extension installed on here, which I really enjoy using, and it's called REST Client. And it looks like this. And what you can do is if you use Postman or if you use any sort of utility that allows you to make HTTP requests, this works really well in order to use it directly within VS Code. So I have some code that I'm going to paste in here as well. And I'll create a new file and I'll call this requests.http. And so I can just tell this extension that I'm going to be sending a post request to this location and tell it what kind of content I'm sending and then give it a payload. And I can do this all within VS Code. So let's start a debugging session here with our brand new API. And that's going to load up. While that's loading, let's come back over to my Storage Explorer and find the new storage accounts that got added when we created the Functions app. And I think it was CRS Reliable Web Summit. Let me go back to Azure and figure out what it is. So CRS API Demo Storage. Here we go. All right, so you can see within here, there's the messages message queue. And within the tables, we have the volunteers table. So this is what we'll be looking at to see if our test data shows up in here. So we can bump this over and within VS Code, bump that over. Oops. I have another, I have my demo version of the app running on the same port. So I need to close that off so they won't be fighting for the same port. So we'll come back over here and start that debugging session again. So we'll see the output here, and in a moment, it'll say that it has that HTTP endpoint as well as a queue trigger endpoint available. So this is all running. So here's the HTTP endpoint, here's the queue trigger. So now by using that extension, I can just click on this button to send request. Here I get back an HTTP 200 OK. And when I refresh, you can see that there's my test data. Perfect, that's working great. All right, so let's delete that. And we can stop debugging for a moment. And now what we can move on to is using the Azure Static Web Apps CLI. Now, the reason this is important is because we have these two different applications that are running separately. So I have this UI app here, and then I also have that Functions app. And so what I want to be able to do is on my local machine is be able to run them the same way that it would in the cloud. And I already have this installed, but I want to show you the command to install the Azure Static Web Apps CLI. So npm install, you want to install it globally at Azure Static Web Apps CLI. And what that will give us is a number of different commands that allow us to run the UI layer locally, and then also point it to the API layer so that it all works together as if it's the same app. So it takes care of CORS issues. It takes care of all kinds of things for us. So let's go back over to the Functions app, and I close the debugging session. I'm going to start that back up again. So I want to get this running and have everything available through port 7071. So once this kicks off again, you'll see that it's available. And we're looking for green text. There we go. So everything's available through port 7071. That's perfect. Now I'm going to come back over to Visual Studio Code for the UI project. So here's that HTML file that we were working with. I already have the CLI installed, so now I can run a command that will start up a local development server for the UI and glue together the API version for it. Okay, so let's do SWA, start, and then I'm going to point it to an API. So --API, move the cursor out of the way, equals localhost 7071, and we'll kick that off there. So now you can see what's happening here is that the dev server is at 7071. It's running the static content from this location, and now everything's available through port 4280. So let's come back over here, and this is my original demo version. So let's refresh this. All right, now I can say Craig Shoemaker. So this is now pointing to the new version of the API that we just built. I can click on that. I come over to Storage Explorer, refresh, and there we go. We've got Craig Shoemaker. Everything's working very, very nicely. Okay, so now what we want to do is publish. Since this is working, let's take this Functions app and publish it up to Azure. So I can come back over to the extension, click on this local project, and go to this deploy to Functions app. So it was under my Docs R&D subscription, and let's find the API demo, Reliable Web Summit API demo. And am I sure I want to? Yes, I would like to go ahead and deploy that. So that's going to be running in the background. It's going to package everything up, send all of the files up to Azure, and make sure that that's available through the instance that we created. So as that's running, what we also want to do is go back over to Azure, and let's go to the static web apps and find the instance that we have here. Okay, so this is where the rubber meets the road. So we have everything running in Azure. We've got the Azure Static Web Apps UI running as an instance of Static Web Apps. And then we have an Azure Functions application that exists as two separate services within Azure. So what we want to be able to do is link those two together. So what has to happen here in order to make that happen? I'm going to go over to hosting plan, and I'm going to bump this up from the free plan to standard. So if you're following along, for demo purposes, it's really cheap to do this because you can delete it afterwards. But the standard plan is required in order to link to an existing Functions app. So I'm going to bump that up to standard. And now let's see if our function is done deploying. And it is, okay. So it's completed, and it's asking me if I want to upload settings. So those connection strings that are in the local settings.json file, it's going to, this extension, if I click on that button, as I just did, it'll upload all of those settings into an application settings area of the Functions app. And that's perfect. That's what I want. So now, if I can find my cursor, I can go back over to the Azure Static Web Apps. So this is the RWS, the typo AUI. We were just in hosting plan. Now what I'm going to do is click on Functions. Now from here, I have the ability to link to a function app. Okay, so here is my RWS API demo. I can link it to that. And as that's running in the background, now we have that link between the static web app and the demo. Now there's one more thing that we have to do though. We have to go and change our value inside the static web app. You remember this workflow configuration file I showed you in the beginning? So we have the app location, API location. At this point, since we updated in the portal pointing it to an existing app, we need to blank this out. It just needs to be a blank string. So we'll do that. What's nice about this is as I make a change to my application, so I'm going to stage that commit and just say chore. I always type the worst when people are watching. Update configuration file. Okay. Commit that. Stop the CLI. Push that up to Git. Now, since I made a change, what that means is if I go back over to GitHub, so if I go to Overview, show you how to find your way around. This is the Static Web Apps instance. I can go to my GitHub Actions. That pops me directly over to GitHub itself. Here I'm at the Actions. I can see the build that's running in the background. I can dive into this a little bit more. And so I can just watch the steps as they happen. So this is doing an entire build process. And again, if your app's more sophisticated, it'll run that build for you. If you have a front-end framework, if you have a server-side rendered app, it'll do all that building and compiling and everything for you. And then what it'll do is deploy everything out to the production location. And so as we watch this, you can see it's running all this stuff in the background. And once it's done, we'll see a message saying polling on deployment. That's good. Once it's done polling on deployment, then it will show us the location that it's available. And so when that is complete, then we can go back to the production location of our new application, run it, and we should see all of the data as expected. So this is almost finished, complete job. That's what we're looking for. Okay, so back over to Azure, I can go to the URL. So I want to make sure I'm going to the right one. Here's our sign up. And so I can say, Craig Shoemaker is volunteering, click sign up. There we go. And now when I go to my volunteers table, there's my new data. So this is all now running within Azure. Both applications are working together. And the key here is that what I have available to me is a Functions app that gives me opportunity to work with message queues, to work with table storage, and basically to trigger off of other types of triggers and bindings of capabilities that are restricted under the standard plan of Azure Static Web Apps. So we have these capabilities available to us if you glue them together in just the right way. Thanks so much for hanging out with me. This has been a whole lot of fun. Let me bring up my slides here again. So reliable systems in Azure Static Web Apps. Again, I'm Craig Shoemaker. I really appreciate you hanging out with me this time. If you want to connect on Twitter, if you want to connect on GitHub, I look forward to hearing from you. Thanks a lot.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.